WI Bombay section presents you with WEBCON, a webinar series. So, what is WEBCON? WEBCON is a 3-day webinar series where you will get an opportunity to explore new areas of knowledge you haven't witnessed before. In this webinar series, experts from various fields in technology are going to enlighten our students with their knowledge and make it an interactive session. So, let's start with the day 2 of this 3-day series. Today, we are going to learn about cloud computing. Cloud computing offers rapid innovation, flexibility in the resources, and economies of scale. It enables your business to communicate and share more easily outside of the traditional methods. Our guest speaker for the day is Mr. Amar Kalvikatte. Mr. Amar is a technology leader in pre-sales and business dev at Nutanix and is currently serving as technology advisor to INSEAD. He completed his MBA from University of Amsterdam. Sir is currently working as a Nutanix cloud solution architect and technology leader for Europe, Russia, Middle East, Africa, UK, and Scotland. Mr. Amar would guide the beginners on how to start themselves with cloud computing. Sir holds a vast 20 years of experience in technology and management and has worked for TCS, Capgemini, and Wipro. He is the ex-CTO of Liberty Global. Besides all this, he loves to guide young minds through his session and currently is serving as technology advisor to INSEAD and is also an alumni at Harvard. If you have any doubts, please raise your hand. You will be given the mic access. I would now request Amar sir to proceed with the webinar.
Yeah. First of all, check whether I'm audible. Hello?
Yes, sir, you are
Yes, sir.
audible.
Okay, fantastic. So first of all, thank you so much, SIS College of Engineering, Shruti Patil, Nikita, everyone who basically helped me to bring to this level today. And like I said, this topic is all about cloud for beginners, meaning you don't need to know about cloud, but before you need to know something about what is legacy and how we can move to the transition of cloud. So I try to cover maximum slides, making sure that you understand at the end of the day, what is cloud? What is the journey of cloud? Not only the journey, but what is digital transformation mean to you? And it's not about digital transformation, but also how the organization are changing, because it's our technology, we can change it, but people who's working there, who has also transforming with their knowledge and the skill set, as well as the mindset they really need to. It's not about the knowledge, but it's also mindset, whether I would like to be part of that new era, whether I would like to be part of the new journey where we can fly together. And with that, I basically propose a small agenda, but with that agenda you learn a lot. So the agenda we're going to cover is, what are the challenges currently out there, why cloud is born, what are the benefits you want to get, and who are the providers there, right? Of course there are a bunch of providers which we'll go through, but and some of the use cases, maybe why cloud is so popular, what if a customer like us, customer like you, how customer are making their minds why to use cloud and how to use cloud. And before we go how to use cloud, it is important to understand some of the components within the cloud deeply, without which we cannot go to the customer and say, you know what, customer, cloud gives a lot of benefits, but if I don't know what are the benefits and how basically we solve the puzzle which you are currently going through, or the pain points or the hassles going through, I think we will not stand in front of customer if you don't have the proper knowledge about the components, the infrastructure, the security, because important security to understand what are the different architectures. And then lastly, we will cover about, because this session is for you personally, to understand you are into the final or third year of your engineering career, where you want to land in next 3 to 5 years. Because if we don't plan from now, then actually we'll fail for the whole life. But so we need to plan together that how you take your journey. Of course there are some people who might not go into that direction, they may go into different direction, but important to understand what is my career plans are. It's not about cloud. Cloud is just in a small puzzle of the equation, but you need to understand, okay, tomorrow maybe I'm not going to the technology, maybe I'm going to UPSC services, IAS, IPS, but of course you need to plan everything. So let's put that way, this session is not only about the technical or cloud itself, but this session is also need to learn about why you want to do this exercise. What are the things I need to do out of this? If you may not get some of the concept from cloud, but you definitely get the concept of what you need to do as a person. What are the challenges you will get and you will face? So let's and keep some minutes. I'll put my time on already. So make sure that we cover Q&A. Ask any question. There is no stupid questions. Make sure that you get clear, because at the end of the day, we all student. I'm student today. I'm student tomorrow, because learning will never stop. And be curious to ask questions, because the curious people only flourish. So make sure that you ask questions, and the more question you ask, the better understanding you will build for yourself. Of course, bunch of certification I will gather, which I achieved. These are my certifications, but certification is not important. Knowledge is a power. So create knowledge within, create create something where customer will always salute you, customer will always want to come to you. With that, I would like to start my session. So as you know that we are into the fourth industrial revolution. I mean, of course, you know that there are every 10 years there is some kind of disruption comes, some type kind of technology comes, and we all need to jump in, and we all need to learn every single day, right? So if you look at in 17, of course, we were not there, but industrial revolution came as a first revolution. Then electricity born, where with electricity we start basically looking at different options. Then if you look at 1990s, where more or less we born in that era, where the computing came in picture, like started with DDoS, DOS, then Windows, and now we have Mac and Apple and the iPhones. Everything, like everything is mobilized now. And but is that computing is the way? No, now computing is just one foundation for that. But now if you look at into the today's era, it's all about intelligence, right? If you look at today, everything is about intelligence, machine learning, artificial intelligence, I mean security, which is also cryptocurrency, all that's integrated together. And if you look at every why we are doing this intelligent part, is because everything is going to be digital. Digital mean everything is going to be online. What does that mean? Is if you look at the IoT chips, Internet of Things, every small, even a refrigerator will be smart enough to see from the rest of the world, even if it is connected to the internet. And you are traveling to US, you can see how whether the refrigerator is full of XYZ or not, right? If the trays is full or not, you can even order, you can fill it. I mean, that's how we are going to drive in the next era of industrial revolution. And smart, which is if you look at smart cars, smart devices, smartphones, smart because they are connected to the internet, they are online, right? And that's where basically we need to create an intelligence. Of course, the AI and machine learning, it's not new. Actually, if you look at Google is already using AI machine learning for more than 15 years, because if you look at Google Maps is not born here 2005. If you look at 2005, AI and machine learning was already part of the Google equation, and they were already basically integrated. But these buzzwords will pop up, and then we need to think, oh, what's the new stuff in the market? But if you look at majority of them are not new. Google is already an example where Google Maps will tell you if you put source and if you put destination, it will immediately calculate how much distance you need to take from source to the destination, and immediately tell you which path you need to go, left or right, right? So that intelligence was already built. So if you look at the five strategic pillars, of course, now we are moving from cloud to the next journey. You need to understand what are the five pillars. As I said, artificial intelligence is the core to the business now. IoT, because every single device is going to be on the internet. That means it's going to be smart, going to be digital. Then blockchain, because of course many ledgers are changing. If you look go to the banking or BFSI's, banking, financial and insurance companies, the blockchain has become the description for them, right? Because there is no, probably there will be no third party in between which unnecessarily consuming the money. For example, if you are buying house and I'm you're a seller and I'm buyer, what I need as a buyer is a house and the paper, and what you need as a seller is you need money from the buyer, right? But I don't trust you, you don't trust me. There is a third party in between, which is going to be bank in the future, right? Just an example, who say, you know what, I'm giving you money, and I have to hold the paper because you're taking the debt. Why do we need third party like brokers, third party like mortgage companies? Because that they unnecessarily consume $2,000 just for nothing, keeping the papers and keeping the money for a few days. So that's where the blockchain is going to be popular, and I think most of the bank is already started adopting as a service. Now look at cloud. Of course, cloud is the foundation of everything, right? because with my friend who introduced, cloud is become the foundation of every digital businesses, is a core to the every digital businesses. And if you look at last but not least, big data. If you don't have the data in hand, you cannot basically write algorithm, you cannot run the ML and AI on top of it. So data is become new oil, new currency, or new gold, you can say that. So these are the five important pillars I personally feel uh, in the strategic business pillars moving forward for next 10 years. And I think if you, one of you who's going to be in technology, if you know either one of the two, you can still be a successful architect, successful leader in the market. Okay, now first, of course, we talk about technology, but this session is not about just the technology. This session is also about the business. If you don't understand the business, I think understand technology is not going to solve the problem. So first, understand the business. What is mean by business? Even if you tomorrow, after passing your engineering and you start working for a customer, before you start any kind of coding or any kind of implementation job, first ask, try to understand about the customer. Okay, if I'm going to work for a customer called, let's say Tata for an example. If I'm going to work for a customer Tata, what is the customer is, what is the vertical they are working, what is their applications landscape, why I'm doing this, what is the impact is going to happen to the customer, and what is the financial things I'm going to solve for them, because business means money, right? If you look at the college, SIES, or any South Indian community they are running, at the end of the day they are making money, right? If they're not making money, they're wasting time, their time, your time, everyone time. So they are making money, of course, right? But money is one part, but also they're adding value to your career, they are adding value to the society of new generation of technology, right? So that's mean they have to create the valuable students and the competitive student who can go and add the impact to the society. So let's assume that I give an example from business, right? Understand business, simple term, you will understand what is mean by business. So let's assume that a Unicloud, which is my company, for example, I'm doing consulting. So let's assume that, take the example of this one. So I have a company, I have a product, okay, but that product I cannot take to the rest of the world because I have, let's say I have not enough money to make my business across the globe. So what I do, I go to the bunch of investors, I go to the shareholders, investors, from whom I borrow the money, right? Of course, you can go to the bank, but bank will give you the loan, but then you need to pay the principal and you need to pay the interest rate, which will be costly solution. And of course, they become the owner, right? Of course, the shareholder is owner, but they think for a long term, because the ideas which you presented will always flourish for them, right? So if you look at, I have the company, I need money, so I go to the shareholders, they invest in my company. What I do, I make that product and go and build that product and sell to the home customers, right? Because if I don't, any product, let's say Amazon Web Services is a product, who are they selling to the customers, right? But if customers now they are using my product and what they're doing it, at the end of the day they're paying my bills, right? Once they pay the bills, what I do as a company, I keep the margin and then return the money or dividends back to the shareholders. Why is that? Because of course they basically put the money in my business. It's my duty as a company, if I make surplus profit, if I make more profit, they need to get some returns. Of course, if a company has been sold, they get maximum money, but of course behind the scene they also need to see like how my share prices are increasing, how the, if my profit is surplus, how much they get the dividend. And then basically what happens, they keep investing in your business. And that's how the business works. Of course, we are talking about technology, but technology is comes between the product and the customers, and here we need to focus on, that's the reason I said you need to understand business, because if you don't entertain to the customers by providing the technology services, by providing the services which not only just configuring and building, but also if there is outages, if there is a problem, you go and solve them. That's where your technology skills comes in picture. But if customer is not happy, your business is not happy, the shareholder is not happy, any of the equation goes wrong, the business is becomes bankrupt, right? So make sure that your customer, like I said, I will focus. Technology is one part of the puzzle, as I said, but first important thing you need to understand customers. If customer, for example, if let's say you are a student of your college, if your professors, your principal is not treating you well, they're doing something wrong. because they need to understand that you are customers. If you don't come to the college, you don't pay the fee, they don't get the salaries, because you are paying the bills of them, you're paying the bills of the investors, you're paying the bills of your professors. So they need to respect you as a customers. It's not about other way around. Of course, respect goes two ways, but customer first. I will tell you first thing, and this will, remember this word. If you become the future leader, customer is always right. Customer holds the cash, so he's always right. So respect customers. So if you look at, I'm talking about customer, what does that mean is like, impact matters. If you look at, oh, data analytics important, knowledge important, yes, but what is the impact you're going to add to the customer? If there is no positive impact or service, or excellent service, I would say, then customer will not stay with you. If you look at Amazon and Flipkart, there's a competition in India, and now Diwali session is coming up. If they are not offering the right services with the right, let's say if you order television because it's a first smart TV, and if it doesn't come in time because Diwali is tomorrow and TV comes after 10 days, you will not hang out with Flipkart. We will buy the next product from Amazon because the delivery is faster. Every single journey to the customer really matters. The service, the product, the packing, and everything. So we need to think about the customers, right? Okay, now why I'm talking this, you need to understand the challenges. First 10 minutes will be little bit of business, but then we come to the technology. But if you don't understand the business, the challenges, I think the technology is not going to solve your puzzle, right? So think about today, if there is a word called DVUCA word. So FUCA is basically the velocity, uncertainty, complexity, ambiguity. If you look at everything, even organization, your college and everything, there are so many layers in between, right? Even if you look at the professor, the assistant professor need to talk to associate, then the HOD need to talk to principal need to talk to the director and the board of directors. So many hierarchies. If associate direct, let's say professor has a query and really wants to make an impact, he has to go to all the layers. But if you look at the startup companies, as a person, I can talk to my CEO, I'm a boss, and immediately the problem is solved because my customer is surviving. So many complexities and velocity. As I said, velocity means the speed, the temp to the market is really important. And as I said, complexity is really adding everywhere. And important is diversity, because if you look at diversity means everything, people from different country, different part for the part of the India, and working in the same company, because they bring different minds from, let's say, in Mumbai, Maharashtra, Kolkata, Delhi, and South. They bring all together the knowledge. So basically what happens, if you try to sell the product, everybody will buy it, because you put the ideas about how customer buying behaviors are, how the business buying behavior is. So that's the reason diversity really matters. But these are the complexity, you will face it. Now, if you think about the C-level perspective, the CEO, CFO. If you look at the CFO, the important thing for the CFO is Chief Financial Officer. What do you think? How can I make the more revenue and reduce the cost? What CEO think? Okay, how can I sell more? That means I'm adding the more revenue, more margin, and operate my business effectively. And of course, if you go tomorrow, it's all about the top management, top to bottom versus bottom to top. Of course, bottom to top will goes, but who makes the decision? Who basically think about going left versus right? The C-level people do that, right? And if you don't understand, then maybe you will survive like, okay, I have ideas, but it's not working because your CEO is not convinced. Your CFO is not convinced. I will go speed, because then of course the session is for the cloud, but of course you need to understand the business and little bit priorities before. If you look at the top management business, C-level as a CIO, Chief Information Officer, because his main motto is customer experience. If my customer is not happy, I'm doing wrong business. If cloud is not the right solution, and but with cloud basically I'm adding not customer satisfaction, cloud is not right value proposition. But if you look at 93%, or maybe number is close, should be 100%, because if the customer, as I said, there is no customer, there is no business. So you need to improve every single services, your communication, your delivery, your proposal, all needs to be exactly the same. That's the reason we call in the management is supply and demand. If customer has a demand and you are not providing the supply, and don't go hand in hand, then when you are doing some kind of mismatch there, and then customer will you lose the customer, they will never walk to you. If you look at today, right? If you look at today, as I said, the data analytics is taking key. Smart hospitals, even let's say smart cars, everything is changing because digital means what? Everything is IoT connected, everything is internet connected, everything is smart because the like I said, the internet is available there. But if you look at the data collection, if you look at everybody has a smart watch now or smartphones, and if you look at Google is collecting because Google has your data. Everybody is configured Gmail there. That means they exactly know where you are, what kind of things you're eating, everything. Because the moment you put something on a Facebook or everything, they knows it, right? If you look at the US election is coming and the Facebook guy knows everything about what's happening in the election because they're collecting the data. And if you look at the data, the 5 terabyte for just collecting the transaction from every single day from the smart devices. If you look at the smart cars, 4 terabyte of data per car, the self-driving cars, right? If you look at the hospital, 3 terabyte of data because they are collecting all the patients and some of the inputs to make the hospital smarter and smarter. So as I said, like we need to be sure that how we can adopt the cloud as a technology who has in immense scale to fulfill this data, right? Because data gathering, of course, data means what? We know that I will tell you how that data means to you in the next slide. So you will understand where we are spending and why we're spending. Of course, now this is where our session start now, right? Now we're gonna build about cloud. As you know, probably in the third year or fourth year, we already have the subject called OSI model. Yeah, open system interconnect. That is the networking stuff. But of course, if you look at cloud, is more on the networking side on the other side, because cloud means what? You need to understand if the application is there. Of course, the application need to talk from source to destination. Let's say if my source is in Mumbai and destination is in Delhi, of course there are two different application or two different client server model, and either somebody is consuming or somebody is basically trying to consume that, right? So if you look at the layers, data length, physical, that means a cable. You need a cable to take data from one source to another. You need switch to connect to the computers, right? That means the data link is come. Network is a router, route the packet from via Mumbai, via Delhi, via let's say Singapore to go abroad. Then you need transport layer where firewall comes, firewall who's protecting your incoming outgoing traffic. Then session presentation and application, that part of the application, that means there's an application stack. If you look at the HTTP based application or Oracle based application, that's where the application comes. But of course you need the model to understand. Now, if you look at, probably you will think about Amar, you called about talk about the OSM model. Now let's go to the era of edge computing. So first you need to understand what is my application means, what is my server means, right? So application basically sit on top of the server, right? But what is mean by a server? Because we are talking about cloud, you need to understand the server first. If you look at this, a legacy server, a server, nothing but what? As you already know, it's in a compute capacity with this bunch of CPU and the memory. And then if you look at storage, C drive, D drive, and then you buy external hard disk because you want to store your data, right? You're buying continuously hard disk because you need to back up your data. You need to be sure that you're not losing any single file of it. And importantly, the network where you connect to the either RJ45 cable or wireless in today's world, where you need to hang out to the internet. So this is the basic component of your server or your even a laptop. If you look at your laptop or even a smartphone, if you look at smartphone also has the CPU and memory and storage and network. Without network means wireless, of course, without which you cannot basically communicate to the rest of the world. Yeah. So this is the legacy server, which is we call bare metal server or physical server. Now everything is virtual, which you don't see in the cloud, but more or less in the cloud is the same thing. They have the physical servers, but they basically put the one server as a share model because you don't want to buy the whole server. They buy the server, but they put bunch of customer on it. That is called a multi-cloud. Sorry, multi-tenant. Basically, there are multiple tenants. If you look at the building, which is a server, in that building, if you see there are 5 floors and 20, let's say 5 floors, and every floor has 2 rooms. So basically, there are 10 different tenants living in the same building. It's the same thing. Server, one server, and then 20 customer. You can live in the same 20 customer on the same server. That's where the model is operating. That's where the shared responsibility, shared services model come in picture. If you look at the server, you might have also heard about containerization. You also have the function. So if you look at the physical server where we have the storage, the memory and everything, but it also has that operating system, Windows, Linux, Ubuntu, CentOS, name it. And then on top of that, you run an application. That's a physical server. Then you have the virtual server, which VMware, even if you look at cloud services, which I just mentioned, the tenant approach, you have the one physical server and there are 20 tenant seat or 20 virtual machine or application seat with the same server. Then you have the Docker containerization. What is mean by that? Of course, you have the physical server, but containerization doesn't need the hypervisor. I'll talk to you about. Then there is a Lambda. Lambda, if you look at Lambda, which is serverless computing. What does that mean is you don't need server. You don't need to manage the operating system. You don't need to manage anything. What you need to manage is just a code. Code means what? If there is a event happen, let's say somebody is going to turn off the computer mistakenly, but you don't want to do that. So what you can do, you write a code that the moment something is going to happen, you insert the code and that mitigation will happen and the server will not be reboot. Because you're pushing the server, you are basically recommending the code to be executed. That's where the Lambda, which is function as a service, comes. Function as a service is nothing but a serverless. That means you are not managing services, but you are managing the code. And everything today is coding, like CI/CD pipeline or even infrastructure building. Automation is part of the coding. That means you need to write a Python, YAML, or .NET or JSON script to make sure that the infrastructure is automated and there is no manual intervention or no manual errors. Rather, you run it part of the automation with the scripting. If you look at, like I said, somebody asked me again question, sir, I did not understand what is the difference between Docker and the virtual machine. If you look at the virtual machine, what is that? Basically, you buy a server like this. You in the server, you have the software from Nutanix or VMware. And basically what happens is basically we add the layer in between is called hypervisor. And hypervisor is nothing but a managing the virtual machines. But how the equation is, so if you look, if there is a physical server and I need three different customer to build on the same server, so what happened, I build application one for customer A with let's say Windows operating machine, customer B with Linux operating system, and customer C with Ubuntu operating system. All three operating system run on top of the physical infrastructure. And that's where Amazon, that's where looks at Azure and GCP, they are all adding as a virtual machine. But you don't see that. You only see your virtual machine and application. You don't see the underlying infrastructure because that's managed by them. Other hand, if you run the container, what is the difference between this and that is, you look at here, you are removing the hypervisor because you don't need hypervisor. What you need is a Docker engine. If you know the word Docker, as alluded here, Docker is basically think about, why do I need a hypervisor? Why do I need guest operating system? And also I have the base operating system. Of course, you need to buy a bunch of, it's better to create one single operating system and run just application on top of it without having the guest operating system. So that means they reduced so much of overheads on the servers. Overheads means what? If you look at this application needs to talk to outside, it has to integrate with hypervisor. That consumes more CPU, more memory, and of course more money, because the more CPU, more money you burn. If you buy external RAM or memory, you still need to pay for it. That's the reason I said you need to burn the money behind the scene. That's where container is born. And also it's not about money, but it's also about the capacity management of your server, the performance, because you're basically offering a service, means customers want to see my application is always available and always high performant. That means the moment you put www.unitcloud.com, the application open like immediately, like with maximum speed. So performance really key for you. So let's move forward. So you might think like, okay, I have the servers, I have even the containerized platform, everything, but where I'm gonna put the servers? So if you look at the traditional data centers like this, What their data center has is a rack. So if you look at, there are a bunch of racks in the data center, and the rack is full of servers. Yeah, these are the servers. This guy is putting servers in the rack because there is a space available. So he's just pushing the server. So this rack is full of servers, switches. If you look at so basically servers connect to the switches, switches connect to the routers, and that's how the connectivity goes. But what happens in the data? See, cloud is nothing but the data center like this. But of course, I will tell you what is the difference between the traditional data center and the cloud data centers, because the buzzword came cloud is, of course, there is a lot of buzzwords, machine learning, AI, and this and that. But at the end of the day, they are just buzzwords. But in reality, what happened? There is the innovation, like there is a legacy, and they need to solve the problem. They create an innovation. They put some buzzword. That buzzword becomes the 300, 400 business value in the market. But you need to understand why. As I said, that's the reason you need to understand why. And I will tell you, there is one book at the end of the day. Sorry, end of the session, you will see that you need to learn that book, because you understand. If you don't understand that, then you never understand anything. So if you look at this one, the data center is nothing but full of racks, and the racks is full of servers and switches and routers and firewalls. That's all you need to manage, and that's on top of that the application seat, right? So if you look at now legacy 3-tier architecture, of course these are the legacy tier, but how that work? I'll give an example where you think like how really the technology works, how basically I access my application. So let's assume that you are a user on the internet, and you want to go to, let's say, X web server, let's say amazon.com, because let's talk now AWS cloud. So amazon.com. So as a user want to go to amazon.com, that is web server which is hosting your applets, and the moment you go there and the page is open, what happens? The traffic will be routed to the router, and they exactly need to know where my web server is located. So basically the internet, of course there is a public IP which attached to the web server. You need to find it out. So what happened? User connect to the web server. Of course web server needs to connect to the firewall internal to your data center, because this is your traditional data center where your applications are sitting. Web is an application. So firewall will open the ports which is only accessible to the web server, because I don't want to expose my database to the rest of the world. Otherwise they will get my customer data. That means if customer buying from Amazon, if somebody hack the customer database, that means they hack my personal details, my name, my address, my credit card number, my all the details, which is very important for company to protect. So if you look at what happened, the user come to the web server talk to the application talk to the database. If I give to simple example, you open Gmail, what happens? You go to gmail.com, then you basically the page open. That means you land on the web server. Then the moment you put your username and password with an authentication or even extra, let's say token, like we called in the banking, OTP is one-time password where which is sent to the authentication device. You log in with it, because even if your device is hacked, the third-party device is not hacked. So that means he cannot log into your application. So once you log into the application, then what happens? You try to basically pull the file which you need to read as something. If let's say Amazon give an offer letter, you need to offer letter which is basically saved in the database. So basically what happened? You open then application contact to the database, the file is open, and then the user get that file. Just in a simple example. But how that works? If you look at here firewall has some protection mechanism. What does that mean? The any means user need to just connect to the web server. So what happened? The internet needs to be only accessible to the end users and to the only web server, not to the application, not to the database. The web will talk to the internet as the next line, to the app, and the app needs to talk to the database as the next line. So for example, look at this, how the equation work. And this is the same equation, even if you're going to the cloud tomorrow and you are opening something like, and this is how it is the world work. If I need to go to the SIES.com, even the user, they basically have the same architecture. Even if your architecture here or in the public cloud is always 3-tier architecture, which is web, application, and database. And if you look at the racks, which I just explained, let's put the equation now. Let's say I have the web server here, I have the application server here and database. All the servers sit in the rack, and that rack you need to manage it. And the rack management is basically the data center in the public cloud as well. But they manage it, you don't need to manage it. But I'll come to that in the next phase. So now if you look at the TCO, before I go to next slide, you need to understand in the legacy data center, you need to understand that as a customer, I need to buy racks, I need to buy servers, I need to buy switches, I need to buy everything, right? So that means I'm buying everything and then I'm managing application on top of and maintaining it. Now, and what is that happen? There is a fundamental financial term called TCO, total cost of ownership. What does that mean is you need to have the TCO, which is nothing but a capex. That means capital investment or initial investment. So you need to buy servers, firewalls, load balancers, applications, operating systems, licenses. You need to rent that space in the data center. So you put initial investment. Even if you buy a house, you need to put 50 lakhs and then the another 50 lakhs you need to borrow, but you need to first invest something, then you need to maintain something. So operating costs is about licensing, maintaining, cooling, power, electricity bills, all that, and then employee salaries, and somebody's managing your data center on behalf, all the costs you need to bear. So if you look at as a company, if you operate as a data center, you need to have the initial investment, plus you need to have your operating cost or expenses. You know what, hang on, cloud says, you know what, cloud said you don't need to buy anything now because we bought everything for you. You just consume the services which you need to your business. That's all. You don't need to buy the anything from anyone. We bought routers, we bought racks, we bought servers, we bought everything. So the capex is out of the equation. So cloud is born for only OPEX. OPEX means don't buy anything, just consume from us. We already bought it. We already have the servers, compute, storage, network, databases, everything you have. What you need is just think about what kind of application is going to run and what you exactly need. And that's where you only pay for OPEX, which is pay as you go model. That means what? If you take 10 machines, you pay 10 machines. If you run for 10 hours, pay only for 10 hours. If you are not using for the 11th hours, of course we don't charge for the 11th hours, because the more you consume, the more you pay. If you less you consume, less you pay. That means, and tomorrow if you shut all the machines, you are out of the business. You don't need to pay anything. That means you don't need to buy anything and maintain for 3 to 5 years and then continuously pay the additional cost. You don't need to do that. That's where the cloud is born. Now if you look at that, now of course now we are going to touch the real cloud, Amazon Web Services. But now think about what are the challenges we are going to take into account, which will not be there in the public cloud, or Amazon or Google or Azure. So if you look at high TCO, that is means what? You are not buying any servers or everything. That means you are reducing the TCO, right? But the challenges is if you buy there, you have higher TCO. You're paying the initial investment plus the maintenance cost. The longer application deployment. Look, if you need to buy servers, somebody needs to push that server to the data center, somebody needs to configure the server, and then you build the application. That takes 3 to 4 weeks of building cycle, and that you don't see in the public cloud. Then if you look at siloed approach, because server is managed by one team, storage is managed by another team, network is managed by another team, and application managed. So then if something is problem, people start blaming, oh, it's not my problem, it's a server team problem, network team problem, application team problem. So there is a silo approach, which you don't see in the cloud. If you look at the ownership, of course, if there is an issue happen, oh, it's not my problem, it's their problem. So nobody takes the ownership. Nobody basically take the part that, okay, I'm responsible, I'll take the lead, I will solve it. Nobody does that. And the important thing is, as I said, service level agreement. Every solution you offer, there is an agreement you need to sign off. Let's say if Amazon says, you know what, you build my application, I guarantee you. So somebody need to give the guarantee that my application is always available, my application is always there, no matter where you're pulling your application. And I'll give you the example where you will understand why the companies are adopting the cloud and why they're fulfilling the SLA, service level agreement. These are the challenges I personally see and seen my career over the span of 20 years. And now think about the benefit of clouds. Now we'll start the journey towards cloud. If you look at the C level, before going to the cloud, I need to think how the cloud is going to solve three things, which is I always see from the C level, and that's where this slide I put it: risk, cost, and time. So what is the risk if I go to the cloud? How much cost is cloud is going to solve? And what is the timeline I need to bear in mind compared to my traditional data center? And of course, cloud is covering three of them. But also there is another concern I do have is, let's say, I don't know whether you know or not, but tomorrow you move to US or Europe, you will know some sort of regulation things. So GDPR is general data protection. That means if you come to Europe, make sure that you are not violating anybody data outside the Europe, because if somebody mistakenly share my credential to someone, he will screw, and 4% of the company valuation they have to pay. So there is a regulation comes in picture. If you go to Cloud Act in US, Trump will surely screw you, because the Cloud Act says, what, American data should stay in American soil. Otherwise, there will be huge penalties and they can make you bankrupt also. So you need to think those are the concerns. Plus, if you look at cost of refactoring, I have the architecture running in my on-premise data center and I need to take it to the public cloud. What are the things I need to change? Do I need to write a different architecture? Do I need to build in a different fashion my server, computer, network? Or do I need to rethink about how my engineers is going to know? Because the engineer doesn't know the Amazon Web Services, they don't know how to configure, they don't know how to maintain it. So can I take the risk of going to that? So all those puzzles need to be solved before C-level people. C-level means CEO, CFO, and the top management need to think, is that the right model? But the cloud says, what, that's the right model, because that's where these are the concerns and the issue has been already encountered by them, and that's where the cloud has born. So now think about what is a cloud. Now I talked almost 35 minutes now. Now we are talking about cloud. So what is cloud? Probably for me it was a buzzword, right? Oh, cloud means what? I think the servers are in the cloud. Oh, really? Then how they push the servers? I know the flight is going to the plane, and then I see still is the open sky. Those kind of things were there in the mind. But if you look at, as I said, cloud is nothing but the data center which you seen just now, the guy who's putting the servers. The same data center is there. It's just a data center, but it's not yours anymore. It's only of Amazon, it's only of Google, it's only of Microsoft, or Oracle and Alibaba. But at the end of the day, because they buy, they maintain, we just put the application on top, and that's the definition of a cloud. So that's the reason I said, you might think, what is cloud? It's nothing but somebody else's computer, right? There is a computer, but you will rent it for a couple of hours or a couple of days or a couple of years, and you build application on top, because it's not yours anymore. You're not buying it, you're not maintaining, they're buying it, they're maintaining, but you just put your applications. That means you're renting it. That means you are consuming that model. So now think about who are the public cloud providers. Now I talk about cloud. Now I talk about data center. What is public cloud providers? And there is another word is hyperscalers. Who are the hyperscalers? So as you know, as you already smart than me, like Amazon is the first in the industry, followed by Azure, Microsoft Azure, Google Cloud, Oracle, Alibaba, and there are a bunch of other PVH, small companies also offering cloud and data center hosting providers. But these are the five major scalers whose, if you look at Alibaba, is growing enormously in Asia Pac region. Oracle, because everybody, almost majority of the Fortune 500 companies has an Oracle cloud, Oracle database, because of the scale, because of the relational database, which is first term comes in picture. So Oracle is also transitioning their existing customer to the Oracle cloud because of the cheap pricing, and basically also you can trade on, right? Customer can trade on. I don't want to go to the Amazon. If Oracle, if you can, we can move to your cloud. Give me 30% discount. Of course, they can basically make a negotiations. But if you look at it's customer choice to go one versus another. And I'm not saying today, because I'm just covering the AWS, that AWS is best than the rest or not. Every cloud has the pros and cons, right? You need to think about what are the pros and what are cons, and how much pros you are going to take into account than focusing on cons. I always say focus on the solution versus focus on the problem. If you become solution oriented person, you become the successful leader. If you become the problem oriented problem, you will go toward negativity versus positivity. So think about how you move to your journey, right? So cloud is nothing but a platform. If you look at it, this is a Google data center, and I will show you the how the Amazon look like. But at the end of the day, you look the cable and the lights, everything is same no matter where you go, because it's they build the rack, they're adding the capacity. What they every day do, the engineers do, they don't focus on application because you need to manage it. They need to manage the infrastructure. What they do, just take the rack, push next to each other. What is that doing is they're adding the capacity, they're adding the compute capacity, storage capacity, network capacity. Make sure that if tomorrow 200 customers sign off for, let's say, Google or Amazon, do I have the right compute capacity to build their application on top? Do I have the right network to make sure that they communicated to the outside world? Do I have the right storage where they can put the data? And now if you look at the data, I said the smart, if the hospital wants to go to the cloud, they generate data every single minute and second, right? Patient data, something data, whatever they called it. I mean, the data from the third party or let's say outsider doctors who really wants to admit to the hospital, all that data, and that data is growing enormously. Do I have enough storage in my rack? So all that things they basically manage it. So if you look at the advantages now, as I said, there are CEO and a lot of people has a concern about cloud, but look at what cloud is going to give the reality. First, agility. Agility means what? Taking to the business. As I said, in the traditional data center, you need to buy the servers, you need to rack it, stack it, and build the application. That takes 3 to 5 weeks, even fastest if you do it. If you don't do it, it takes 8 to 9 weeks, which is 2 to 3 months. If you look at cloud, you can just sign up with a credit card and immediately build EC2 and run the application on top. It takes maybe an hour. So 8 weeks, which is 2 months versus 1 hour, agility bringing to the market is too fast. Cost saving. Think, you don't need to buy any server. You don't need to basically maintain it, because that upfront cost, which is the capex, you don't need to bear that. It's basically only opex. That means cost, you are minimizing cost enormously. Elasticity. Elasticity means what? It's like a rubber. If you pull the rubber, it basically expand. If you leave it, it comes to the default nature. It's elasticity. That means what? If the demand comes, then you need to add the servers immediately, because you need to make sure that the compute and storage and everything capacity is fully available. So if you look at an example I would like to give, let's say maybe some of the people are trading on the share market, Bombay Stock Exchange or National Stock Exchange in India. So let's assume that 10 o'clock the market open, and something like, let's assume that for example 1 o'clock market close. So 3 hours, everybody who's interested, guys, try to go to that website and try. So can you imagine, by the time the traffic is too much, so what you need to do, they need to do, is they need to have the enough capacity to fulfill the traffic. So that's the reason what happens. They add the number of server in 3 hours, and when the traffic is zero, those added server will automatically removed. That is called auto scaling group, which you will see in the next feature slide. Innovate easier. Like I said, you can just design your application and start building it, because you can roll out your application new feature easily. So there is no you need to wait for anything in the future. Just take another virtual machine, build the application, test it, put into the, because even if you go tomorrow as a professional person, you need to work on 3 stages: development stage, UAT, which is a user acceptance test, which is look like a production test, and then the production, because production is where the real time things works, right? And then last but not least, go global in minutes. And what does that mean? I'll come to you. If with your application, if you built it, take the application and put everywhere across the globe, and you become available in days across the globe. And I'll take you some examples where you will see why go global in minutes. So before moving to that, you need to understand types of cloud, right? As I said, these are the public cloud providers. But if you look at the data center, which I also showed, is a private cloud with Nutanix. Let's, for example, you can build compute network storage and build application database on top. So basically, this is a private cloud where you host your application on premise data center, which is any data center, your data center or rented data center. And Or else you can also build your application on public cloud providers, which is public, and private, which is separate. But if your application is spread across two on-premise and public cloud, you need an hybrid cloud, which is a combination of on-premise and cloud. And if nowadays it's not about hybrid, but it's also multi-cloud, because you're consuming, let's say, Amazon services here, and you want AI or machine learning from Google, and still you need to talk to your data center. So what you do is basically multi-cloud. Basically, you're using two clouds, which is multi-cloud, multiple cloud you're using. So basically, the types of cloud may be private cloud, hybrid cloud, public cloud, and multi-cloud. And that's where the cloud, if you look at it, is called distributed architecture. That means your application is distributed all over places, in the private cloud, in the public cloud, and also multi-cloud. That is distributed all over. And that's where the distributed application, distributed architecture came into picture. If you look at cloud services model, this is very, very important for you to decide what kind of services model I'm going to consume. So what are these? Infrastructure as a service, platform as a service, and SaaS as a service. And I'll give you some examples. If you look at traditional data center, which I just told, show the picture, you need to maintain everything: networking, storage, servers, virtualization, operating system, middleware, runtime, data, and application. So that means this whole stack you need to maintain. You buy, you maintain. Now look at the cloud born with the three models: infrastructure, service, platform. Here he said, what, the orange part, you said, what, these are the Amazon, Google, or Alibaba, or anybody's responsibility. As a customer, you only focus on operating system, runtime, and application. If you took taking infrastructure as a service platform, because you want your own operating system, rather than we provide Linux, but you want Windows, you can run it, and you can run middleware and application. If that is the way customer wants, the customer choose IaaS platform. The customer says, what, I don't need to maintain operating system and don't need to maintain runtime, everything. I just need to maintain my own application. Then you take the platform as a service, because the rest is managed by Amazon or Google or anyone. If you look at the Outlook, yeah, Office 365 or Workdays or Salesforce application, you just need to consume it. You don't need to manage even the application. That's where they provide everything for you. You just basically, even their application, you just need to consume it. We use Salesforce application for putting customer data. For example, if I visit to the customer and I know that I'm going to win that deal, I put all the details into the Salesforce activities, and my CEO, all the colleagues across the globe, they can see what are the opportunities Amar is bringing, what are the deals Amar is bringing, how much is the cost, because we are adding to the existing application. So if you think about as a designer or architecture tomorrow, you need to ask to the question to the customer, because hey customer, what is the choice you want to go? Do you want to maintain application and operating system and data middleware? Customer said, yes, I want to keep my operating system. That means you need to go for an IaaS model. Customer said, what, I just want my application to be managed, the rest managed, I should not be managed. Then you go for and propose a PaaS model versus IaaS versus SaaS. And that's how the industry is moving. And if you look at as a developer, you basically ask, developers are putting a pass, because you are creating everything beneath and application is managed. If you look at infrastructure, is all about hosting, because you are hosting your operating system, you're hosting your middleware. And if you look at SaaS, is all about consumption model, right? And that's where the industry is moving, and these models are really, really important to understand. Now think about Amazon Web Services. I will start and now focus on the only Amazon, because we have now almost 30 minutes, and I'm sure I will cover the rest of the part. So if you look at Amazon Web Services, if you look at, I visited once when I was first telco customer as a CTO of Liberty Global. First visited, and basically I saw how the data set look like. Of course, it is possible for top-notch customers, and with the request and with signing contract, they will allow you to go. So if you look at, you get an opportunity to see the racks and the data center, which is clean, neat, and even better than our own house, because everything is maintained. There's a cooling and maintenance, everything is properly happen. And you see everything is locked also, because even a customer or anyone entered, he should not touch to this, because there is a important customer data should not be unavailable, because customer is paying the bill, so their data, their services need to be available. So everything is locked, secured, no problem. And you see that previous data center rack, which has so many hassle, cable are lying here and there. You see there is no cable lying, there is no unstructured. It's everything is properly structured, and that's where they're maintaining the data centers. So Amazon born in 2005. If you look at maybe in the history, and why they born as Amazon previously, you know that they were only selling the books. And Jeff Bezos, who's the owner and founder of Amazon, he said, you know what? Why I need to create Amazon Web Services or any other services later is because I learned over 20 years of my service selling the book is how I can make the customers customer satisfaction. So in the management term, we call NPS, Net Promoter Score. So how I can promote my customers if they are happy and they promote their customers to buy Amazon only, not Google or something. So he understands the consumer behavior. He understands the buying behavior of a customer, and also the mindset of a customer. And that's where he created a service called Amazon Web Services, which is their cloud offering, which has this enormous scale because they have the multiple regions all over the world. And I'll tell you the numbers also. And that's where 2005 Amazon basically built. They also hosted their first application marketplace, and then they started offering as a service. So internet they reuse. And if you look at Amazon, every company their own application is hosted on AWS because they're also saving the cost, but they're also thinking like how they can do better and better for themselves. If you look at in the market, Amazon is the always, like I said, because they come first, they grab the market all over the world. So if you look at the market value is 9.8 billion last year statistics. This year is haven't declared. So if you look at majority of the stuff, they are getting it 32% versus rest. If you look at the rest is 38 and they themselves 32% in the market. So they are the market majority of the market share, but also look at the number of services they're adding: compute, storage, network, database, machine learning, AI, IoT. They are the one who is putting the services earlier than any other, so that consumers can start taking their services versus any other. So now maybe you think about, okay, I talked about the cloud, I talked about data center, I talked about how born, but keep our security. Remember one thing, your data must be secured. Because as I said, if the data is not secured, you won't trust on that party, you don't trust, and you don't basically make your mind to go to Amazon. So for not only Amazon or Google or Alibaba or any other, they found security is a foundation layer. That means security should go everywhere. So what does that mean? If you look at Amazon Web Services, of course they offer compute, storage, database, networking, everything, regions, availability zone. They basically own the security. So it's a responsibility of Amazon Web Services. They take care about the security, securing the rack, securing the data centers, etc. That's their responsibility. What is a customer responsibility? Because you are hosting your application, so you need to understand what is my security, what is my responsibility within the cloud. So our security as a customer is we need to maintain our own data because we are running on top and they are maintaining this without giving access to any third party customers or even my competitors. So they are maintaining that security, but we need to make sure that our data is maintained. We have the let's say VPN is built, which is encrypted traffic. Firewall is there to not to allow anyone to access my data, only allow to the people who's supposed to access the people. So encryption, integrity, let's say IAM, which is identity and access management. That means only particular users can access it. If there is administrator, if there is only, let's say, database person who need to change something, so allow only the granular access to that end user. Otherwise, you will not want to give access to the hackers who can leak my data, who can reuse my data, and they can make us company and in the cloud platform bankrupt. That's the reason the security is a very focal point of data cloud. And cloud, this, like I said, it's a shared responsibility at the end of the day. They are sharing, basically taking care of something, and you're taking care of something. So that means it's a shared model. Yeah, it's not about like cloud, I take it means cloud they have to responsible. No, if your engineer is open everything to the end user, and something is broken, Amazon is not responsible because this is fixed model they offer you. They said, you know what, the moment you take my IaaS platform, that means data is yours and the middleware is yours. You take PaaS application yours, the rest manage. If you take SaaS model, of course they manage everything for you because application also their responsibility to maintain. But it depends what model you choose, so the security goes along with. Of course, as I said, there are a bunch of other tools like IoT, a lot of functionalities they offer, IoT, let's say DevOps, analytics, data analytics, machine learning, etc. Of course, the SageMaker is a machine learning tool. They have the marketplace. That means you can bring even third-party solutions, which let's say you're using firewalls from Palo Alto or Checkpoints or Cisco, etc., and you don't want firewalls from Amazon, you can bring those firewalls or networking devices from marketplace, which I will cover you later. So these are the broad range of services and functionality they offer. Of course, as I said, like there are GDPR and GDPR, which I said data protection. FedRAM is federal, which is US government, which is federal government. They need a risk and let's say authorization management program. So and plus NIST and Cloud Act, which I said GDPR in Europe, Cloud Act. So data needs to be locally stored, but needs to be secure. So all the ISO, you look at ISO 27000, 9000, all those security certification they already achieved it. PCI, which is personal credit card related information, everything they have taken care of so that they own the security responsibility, they own the regulations. Now, as I said, marketplace, of course, as I said, if you don't want firewall, if you don't want server from Amazon, you want server from Nutanix, you can go to marketplace and you can pull the servers and you are done. You don't need to think about uh, buying server from them only. You can even rent servers from us, and you, because you already have the expertise on, let's say, Red Hat Linux or Nutanix or MongoDB, if you want to, you can do that. Even they also offer a partner network with Infosys, Capgemini, Accenture, and you can basically, with the help of them, you can do consulting and they can help you to build your infrastructure. Now, as I said to you, like, who are the people going global in minutes? You remember the point, go global in minutes. If you look at the company like Airbnb, Uber, and Netflix, of course, we call the virtual companies. They don't buy the, if you look at, you buy your router at home, you pay for the internet, you pay for your television, but then Netflix sit on top of it because they don't need to buy any infrastructure. They just need to sit on top of the internet. And what you do, you subscribe and then you watch televisions. Of course, it's a smart business model. But if you look at Netflix, Uber, or Airbnb, it's available all over the world. That means they have built their application in all the regions, all the availability zones, and the consumers are locally accessing it so that there is a high speed, low latency architecture is there. Now start with Amazon Web Services, right? And now tomorrow you want, after you heard some sort of knowledge, now you say, not sir, Amar sir, I want to go and create my Amazon application on Amazon Web Services. So what you need to do, first and foremost thing, you go to Amazon, www.aws, which is Amazon Web Services.amazon.com. The moment you click on it, you go and sign free tier. Free tier, basically free tier means they give you 750 hours free to make your hands dirty, to basically run your practical approach. So what you need to do, you put your name and email address, you put your basically details, and then of course they need credit card, right? Because if you use over 750 hours of use extra, you need to pay for it. So they need to know where we need to put the charging. So you need to put your credit card. And of course, you also need to think, like, tomorrow if I'm running application and I need some support or like support, that's where I said SLA, service level agreements, that comes here in the management part of basic plan or even business plan, where users, they can access 24/7. You have access to their engineers or their call center 24/7. If you take free, you don't have 24/7 access, of course. So of course there is only one, if you call, then they will say, you know what, not today, tomorrow maybe. But if you take business plan, they will immediately available for you. But of course it comes with a cost. So you need to sign up with your credit card. Once you sign up, then what happens, you start building the applications. So of course, you building application means what? If you look at India here, there's a Mumbai region. So let's say you are in Mumbai. Good that you are in Mumbai because the region is very next to you. So what you need to do first, building an application, where is my nearest region? Okay, nearest region in Mumbai. Okay, I'll choose that rather than choosing the Amsterdam or choosing the California or Washington DC versus Sydney, because it's too far for me. That means I'm adding too much latency, or the, let's say, the performance will be degraded. So I'll choose my local region. Okay, I choose the region. Region is nothing but, as I said, physical location, which is basically, and physical location in multiple data centers. So if you look at a region has multiple data centers, and they're interconnected with fiber optics links and low latency. Fiber optics has higher speed, so there is a minimal latency. That means speed is too fast. Yeah. And if you look at the 226 power of presence, that means there are power of presence where that can help you to do caching and pushing the caching. But come to you that later. So basically the structure is, you have the region. Every region has 2 to 3 availability zones. And availability zones is nothing but one data center, bunch of data center you can call it. One availability zone can have 2 or 3 data center. That means if you have 3 availability zones, you can have 6 data centers within that region. So that means your application will, even if this data center is burn or flight is landed on the data center and the data is gone, you still have application running in 2 data centers. That means your application is always available. If you look at, as I said, availability zones, sorry, region means is the region, a physical location, but now region has an availability zones. Yeah. So availability zone 1, 2, 3, and the names are 1A, B, and C, etc. If you do EU, because I'm in European region, EU West, EU2, whatever. So region West, so which is Frankfurt, in my opinion, which is in Germany. And if you look at what does that mean is, so availability zone is nothing but an IP subnet. So IP subnet is nothing but, probably IP addressing, right? We have the private IP 10 dot network, 170 network, 122, 192 network. So basically what happened, the IP addresses are different. If you look at 10.0.0 and 10.1, that means there are 2 different subnets. We call subnets. So that means zone A has X subnet, zone B has P. That means you can build redundant and resilience application on top of it. Let's move slowly, yeah, because I'm trying to make you progress to make a right architecture at the end. So you have the regions, you have the availability zones where you host your application. These are the applications. So if the availability zone A is a burn, or let's say something goes wrong, you still have application running here, and the end user can still grab that application. Now think about, as I said, you have the region, 2 availability zones. What you do, you combine them, and you call VPC, which is virtual private cloud. Once you combine them, the 2 availability zones become part of the one logical unit versus 2 logical unit. For the end user, it says only one logical unit versus 2 logical units, right? That's where the VPC comes in picture. Of course, what is VPC is, but if you look at in this picture only, you have the IP address, which is 172. This is private IP address, and because this access to the internet, you need public IP address, because internet is all about public IP address versus private IP addresses. And I will, in the next session, if you want, we can go even deep dive. But if you look at what you need is routing also, because if you look at this router, if the internet is coming, then he need to route to this subnet versus that subnet. So routing needs to be done. So let's take an example of what is meant by routing. Let's say you are living in Thane, you want to go to the Borivali, and then you think, okay, how should I go? Like, if what is my fastest route to go to the Borivali? Of course, you can take car from Thane and go to Borivali by car. But then if the traffic jam happens, you go in 3 hours. If you go via Thane to via Dadar to Borivali via train by changing, you can reach in 1.5 hours. Just an example. If fast train or even slow train, fast train will save you 20 minutes minimum. But what you take, you route yourself to take the shortest path. Shortest path means in terms of time. So you take via the other to go to Borivali, that's the shortest path versus taking a car, even if a Mercedes, which doesn't give the feeling of reaching early, because if there's a traffic, Mercedes will stand still. So you need to think about how the router will take you from the shortest path, right? And that's where the router come in between the subnets and the different IP subnets. If you look about now I will give you that little bit higher version. So now you know the VPC, different availability zones and the application, which is front end. Now let's take the 3-tier architecture which we discussed in the last. So if you look at, we have region, let's say Mumbai region has two data centers. So if Mumbai region, let's say Thane data center is it's some issue, still the Kulaba, or let's say the VT or CST data center is available where my traffic can be accessed, right? So let's assume that if you're coming from the internet, you have the front end, so let's say, which is a web server, and the back end, which is database, and in between you have the application tier, same architecture, web application and database. Of course, in the legacy data center, you have the firewall and three subnets. But look at how here is, you have two availability zones. Of course, plus the two subnets, one subnet two. In the legacy data center, you have only one subnet. One subnet for web, one subnet for application, another subnet for database. Here you need 6 IP subnets, because if this subnet is unavailable, the elastic load balancer, which is on the top, will divert to this subnet, because that configured as an auto-scaling group. And that's where, if you look at, you need 3-tier architecture, means 3 subnet. But if you look another region, availability zone, another 3 subnet, which is 6 subnet. And of course, there is a router which will forward traffic in between. So now think about, a user is coming from the internet. He wants to go to the web server. The router will forward to the elastic load balancer, where the public IP address or VIP IP address is configured, which is attached to your EC2 instances. So user comes to the router will forward to the elastic load balancer, and load balancer will traffic forward to the front end, which is the web server. Let's assume that now you come to this web server, and web server needs to talk to the application. It talks internally with the concept called security groups that runs on the instant basis. I will tell you what is the difference between security groups and network access list. So subnet A, subnet B, subnet C. So when there is a two subnet need to talk to each other, their network access list come in picture. When the two instance, let's say web server talk to an application, instant based communication, then the security comes in picture, which is the firewall rule. If you look at the firewall rule, I showed like any can talk to web can talk to application talk to database, same, but that is a firewall. So here in this context, firewall is nothing but a security groups, which I'll come to you later. So what happened, the user come to here, go to the web server talk to the application talk to database, and database also need to basically give back to the file to the end user. Same use case we just talked, but it's in a different manner in AWS. And so what you need to do is your database, which may be burned, so you need to take the backup of the database, so which you do in the S3, which you can do in like when you're the laptop, and if you think if my laptop can go wrong with, if the water falls and then my data will be burned, my hard disk will be gone. So you buy another hard disk, let's say external hard disk, and you as a backup. Same thing you do it here. Amazon S3 is like object storage. You can took your backup and pull it, but it's all integrated within Amazon Web Services. I hope we are in time. So far, so good. So another 5-10 minutes, then we are done. If you look at VPC, default VPC, what you done, as I said, this is all about VPC. Yeah. So in the VPC, you create so first you take the region, you create VPC, then you create availability zones, and you start pushing the application by using subnets into the every availability zones. That's how you start slowly building, and then you create routing, you create security groups, you create and allow some permission, and that's how you do as a series. If you look at here, you create VPC, you attach subnet to the edges, you route it. Then what you do, of course, I will come to this VPN gateway, but you basically allow the instant to communicate. Now slowly go in another 15 minutes, I'll take it, but then you understand exactly. So EC2 is nothing but a compute. Yeah. So we are not buying the server, physical server, we are buying EC2, which is compute instant. So if you look at here, they call t-shirt size, small, medium, large, extra large. It depends on the size. If my size is large, I will buy a large. If I'm a small, I will buy a small, right? So, but then what happens if you look at medium, if I'm medium, it comes with one virtual CPU and 2 GB of RAM. But if your requirement is RAM is, let's say 32 gigabytes RAM, I need it, then you choose extra large, right? Because there is 6, but then you pay extra higher money. So that's where the compute comes. Then if you look at the storage, so look at now C drive and D drive. I'm talking about the computer. This is, let's say, my computer. Let's say I took small computer, big computer, extra big computer. Yeah, then you choose like, okay, I bought a computer. I need a C drive and D drive because my C drive, I have the operating system where I need to do local read write, because if I do, let's say, open the Word file, it needs to open it quickly. That's the reason local read write needs to happen to the local operating system, which is Windows or Linux. So that's where the EBS volumes come. EBS is block storage. Operating system is nothing but a block storage because it's a block of 32 bits or 62 bits, right? And that's where the block comes in picture, and that should be local, it should not be remote. Let's assume that your storage is far away and you are on the storage, your operating system, and you are running the laptop here. You have to wait for hours and hours to open that file. That is not possible in today's world. It has to be instantaneous. So that's the reason block storage or EBS volume is born in AWS. So you will see that EC2 instance, you need to attach EBS volume because you are putting your image there, or image is nothing but a operating system. Then you need S3. As I said, S3 means what? You need external hard disk, external data, which is S3 means is the object storage, which has it's publicly available, has enormous storage. That means you don't need to worry about the capacity. You can put every single data without any problem. But the good thing about S3 is cheaper solution. It's very cheap, cost not costly, but cheaper solution. But if you look at IoT data and devices and analytics, what happens internet because everything is on internet, and S3 is internet based services, which is public services. You immediately push your data to the S3. If you really want to see images, photo images or photoshops, all the images you can put on S3. Even your websites you can host on S3 itself, and you can build your website. If you look at myunicloud.com is hosted on AWS, which is on the S3. So I'm consuming S3 already, where my website, my company website is already part of the equation. Now think about databases. As I said, the web application and database, right? So database is the primary, let's say every organization has a database, maybe small MongoDB or Postgres or SQL or Oracle, depends on the let's say the capacity and the money they hold. They buy the servers and the requirements. So Amazon, what they decided, you know what, there are a bunch of servers, database servers there. Oracle has Larry Ellison, who's Oracle founder. He has Oracle. Then Microsoft has MS SQL. There are some open source databases. But why can't I create my own database? So basically what they create is RDS, relational database. And relational means relation, rows and columns. Basically, you know, like if you like a table, you create a table on Excel sheet. Let's say if you put customer database, then what you put, the name, address, credit card number, etc. And then you put, okay, Amar, and then your name. So basically it has rows and also columns, and that has a relation some sort, and that is called relational database, table based database. And that Aurora, if you look at Aurora, which is MS SQL and Postgres compatible database, but if it is look at, it is 5 times faster than MS SQL and 3 times faster than Postgres. And if you look at from the cost perspective, they're cheaper too, right? And that's where Amazon created their own database, Aurora's database service. Of course, you can consume any other, that's not a problem, but Aurora is their Amazon baby, Amazon database. Now, as I said, security groups, as I said, you have two subnets and two subnets need to talk to each other. You don't need security groups. But if you have two instances, let's say my web server need to talk to application, I need to create an instant based access or allow. So basically what I do, I create only allow port numbers. You see 80 or 40. So let's take the small example. If the user is coming from the internet, he need to have the SSL, which is HTTPS. Once the elastic load balancer is allowed, so basically if you like the security groups web need to talk to security group application. So that means the security group talk to only port numbers. You look, if there is another application which has not this port, the traffic will not be allowed. So security groups is part of the instance, and it is instant based communication, not the subnet based communication. When it is a subnet based communication, let's say 10.10.10 needs to talk to 10.10.30, then the NACL comes in the picture. NACL is nothing but stateless. Stateless means what? If you apply the permission from inbound, you need to apply from the outbound too. That means you need to apply bidirectional, versus here if you apply unidirectional one side, by default the outgoing is allowed. You will learn that later when you study. So we talked about security groups, knackers. Now think about internet gateway, right? What is internet gateway is, let's say I have server 1, server 2, and the server need to make a communication to the outside world. What happens? In the AWS, you attach the internet gateway to your VPC. Of course, it's like one internet gateway only. So you apply to per VPC one internet gateway. So you apply internet gateway and basically allow that machine to communicate to the internet. But if you're not communicating to the internet, so you don't need internet gateway. Only when you need internet gateway, when your communication needs to be either open or allowed to communicate to the internet world. Otherwise, you start paying unnecessarily if you're not using it. Because as I said, it's a pay-as-you-go model. The more services you buy, the more services, the more money you pay. So if internet gateway is not needed, don't even configure it. Otherwise, you're adding cost to them. Now VPN, what is mean by VPN? As I said, I have hybrid architecture. So my server, some of the application running in my public cloud, which is Amazon Web Services, and some of the services are running in my traditional data center, which is my old data center, my own data center, right? But my two application needs to talk to each other. So there are two ways you can build a communication path. One is VPN, which is virtual private network, which is you create a VPN, which is nothing but over the internet. You create 1 GB pipe. Of course, there is a bandwidth is already there, but you need to configure 1 gig or additional. If you need additional, you need to request it. And what you do, you basically configure the encryption in between the two. That means the traffic is encrypted in between. Even if there is a hacker who try to spoof your application, let's say every single packet moving forward, he will not hack it because it's encrypted. Even if you see Amar, if I'm sending Amar as a word, they will see something like a big hashing stuff, the hash dollar, etc., which he doesn't find what is the text I put it Amar. So that's where the encrypt target. So that is one way of communication. But this has come up with 1 GB of only data, let's say the bandwidth. If you want more bandwidth, let's say I want my 2 terabyte file needs to be transferred from here to here. I need more bandwidth. So what is that means? There is another concept called direct connect. So you build a big pipe. In India, we call lease lines, or ISDN is a small 64 lines. If you go to the bank, they will say lease line, ISDN line. So ISDN lines is basically 64 kbps, and if you got lease line 2 mbps, or maybe you can bundle it, then you can 4 mbps. But now, as I said, the traffic is going in GB. We need terabyte of capacity. So basically, you build 10 gig or 20 gig pipe between the two. Yeah. So but you can even minimize, basically ask your partner network to minimize as per your choice, and they will basically help you to build the real fiber connectivity between, and that where you speed will increase and you can push more data than push only 1 GB data over the VPN. Of course, on top of the direct connect, you can configure VPN where you can encrypt the data. But the real time bandwidth you get it is the 10 gig or 20 gig. Now, if you go to elastic load balancer, I just said, if let's assume that, as I said, the traffic is coming in the morning for Bombay Stock Exchange, 3 hours. I have 3 minimum servers. And if the traffic comes, I need to expand it. You look at this arrow, expand it. So I need to expand it to 10 servers. So I'm going to add additional, let's say 9 servers. So I'm going to add additional 6 servers. So that means when there is a demand comes, I add more services. If there is no demand, I keep it back to 3. So if you look at this one, drawing, keep minimum, then add the desired capacity maximum. So you basically scale out your application, which is 2 to 4. If there is no load or no traffic, then bring back to the minimum, which is by default services, which is 3, here 3 or here 2, whatever. So that's how the elastic load balance. And load balance is not about just adding the capacity moving, but pushing the traffic to minimum available services, basically minimum utilized services. Let's say this is 60% utilized and this is 30%. So next user who's trying to access, he will basically forward the traffic to this one. If the server is unavailable, he will take the server out of the equation and he will not forward the traffic to that one. He will forward to traffic to another one. There is another requirement from the customer will say, you know what, I only want server 1 to be always available for me. So there is a call persistency or stickiness. So only what happened, Amar traffic is only stick to the server 1 versus server 2 and 3. That's where the specific demand comes in picture. That's where the load balancer come in picture. Now NAT gateway. If you look at now my database, Oracle database wants to go to the internet. Why? Actually, it should not be go to the internet because Oracle database should be private and should not access. But Oracle database need patching extra. Let's say I want to upgrade my Oracle 11 to 12.x. So I need some patching, some updates. So what happens? That database need to go to outside, only go to outside, not to come to inside. That's where the NAT gateway come. NAT gateway is basically NAT means network address translation, private IP to the public IP. So you are allowing private IP to communicate to the public. So you need a NAT gateway, and NAT gateway will only take Oracle database to go to communicate to the internet. Not internet can communicate database. That's where one-way communication, and you can go up to 45 Gbps of traffic bandwidth. Endpoints. What is endpoints is, look, I have S3 bucket, which I already said to you. S3 is the storage, object storage, and I have my private machine. Now look at, as I said, if you want private machine to talk to the public machine, you need NAT gateway. But NAT gateway means you need to pay for it extra. And plus you need to make a communication. Here you don't need public IP NAT gateway. You just need endpoint, which is nothing but a private IP without NAT can talk to the public IP, which is with the help of endpoints. So endpoint is mean for communicating private IP to the public, which is within the region, not outside the region. Peering, if you have two VPC, if you have VPC 1, VPC 2, let's say this is my UAT and development VPC and this is my production VPC, they need to talk to, you create two VPC peering between so that internally they can talk to. Let's say my region is 1 and region is 2 and they need to talk to, you can create VPC peering. IAM, very important part. I have 5 minutes more and then we are done. Let's assume that the IAM, this is very important also, because if you look at security, let's say Amar is the administrator who's supposed to configure my Amazon Web Services. What is that? You basically said IAM is we call AAA. AAA is authentication, authorization, and accounting. So authentication means what? Amar needs to authenticate it to only the web server, not to the database. So you configure Amar to access only web server because he is a front end guy. He's not a back end guy. The database guy needs to access the database because he is a database owner. So only I allow to create two users. One is front end user and second is back end, and only allow the permission. And if there is more users, just create a groups and add the groups to be like group let's say front end group and back end group. If there are more user part, make that user part of the group and allow group based access, permissions. That's how they access it. Route 53 important. Let's say if you put www.amazon.com, Amazon.com is easily remember names, but they are tagged with the public IP address, right? But nobody remember the IP or numbers, right? I mean, nowadays nobody remember the phone numbers. We just get the phone number, put in the WhatsApp and chat with the names. We don't remember the number. Previously we were using remember the number by heart, but nowadays nobody. It's the same way. If you look at DNS, you put Amazon.com. Amazon.com is basically a name, and then it resolves the IP address band. And IP address is nothing but a public IP, which will take you where is my web server hosted, in the public cloud, in the on-premise. So that's where DNS find. And Route 53 is Amazon service, which is nothing but DNS, domain name services. Yeah. Last two slides, monitoring. If you look at monitoring, everything needs to be monitored. My compute, my storage, my servers, my network. If you don't monitor and something goes wrong, where you basically see where you goes wrong. You can't spend 2-3 days to just find it. That's the reason you need to collect a log, collect the data that will tell you that, okay, this is where something goes wrong. So you click on it and see, oh, I need to only go and compute and fix it. That's where the monitoring comes. So CloudWatch is the Amazon monitoring services where you can watch CPU utilization, memory utilization, network utilization. And CloudTrail is based on API. As you know, everything is API now, right? API is application programming interface, like RESTful API or IAPI or customized API. So you need to monitor all the APIs, and that's where the CloudTrail comes in picture. Of course, trusted advisor. You need to think like, okay, now how can I see like where I'm burning more cost? Yeah, where like I said, where my underutilized resources, because there are uses which I'm not consuming, but they're on, so I'm paying it. So I need to make them off. So that's where the trusted advisor will guide you to focus on the cost optimization, security. If there is a the wrongly configured rules, firewall rules are there, it will tell you, okay, with the sign of this, and tell you, oh, you have 11 wrong groups which you need to mitigate. So you go there, configure in a proper way. If they no need, you just remove them off. Of course, that means you basically add the right services line agreement. Calculator, AWS calculator will tell you before you going to the any public cloud, go to their cloud calculator and put, okay, I need minimum 3 servers, web application database. I need, let's say, additional 2 servers, because if the data center goes, one goes off, another need to be available. You put the numbers here, and then it will generate the cost, and it will tell you how much you basically bear every single month. So before even going there, first calculate how much I'm going to spend every month. Once you feel, okay, that's a good cost and I can bear it, then only you basically go and run the services. That's where the pricing calculator will give you some insight. Of course, now you going to the next phase, like you saying, listen, Amar sir, I need to do some programming languages and SDKs, which is software defined kits. How can I do that? Of course, you can focus on core Java programming, which is has a front end and front end development side. You need backend, you Oracle or MongoDB, you can be DB expert. But of course, you need somebody good at Python, somebody good at .NET, somebody good at PHP, Node.js, which is front end also. So you can use it. Of course, you need to run those things again on the devices, because we have either iPhone, or which is iOS, and the Android, which is let's say Google phones. We need to be build those things at front end, back end, at the end of the as apps only, right? So we need to be sure how we interface the API on top of it. So these are the good toolkits you need to use it. Of course, now last but not least, after my session, go to the website Amazon. If you look at the time is increasing, probably you take 1 hour back from, because I'm talk 1 hour. Microsoft is giving the free vouchers to win freely, so $165. So this is today, because I had yesterday's session with Subhash Chandra College of Engineering, Kolkata, the panel discussion on cloud computing. And there was a lady who's from the Amazon, Microsoft Azure from USA, Texas, and she mentioned that. So I thought, let's better to share with you. So go after this one and subscribe and basically try to win, so that you can give the MCP exam for free. Now, if you're interested, this is where I said understand why. Every time you go, understand, ask the question why. Yeah, because start with why. If you don't get why answer, don't do anything. Even say why Amar Java courses versus cloud courses. First understand why Java, first understand why cloud, and if you get the insight, then only you go for that. But before that, read this Simon Sikin, who is the very talented guy, also advisor to Nutanix, and I got an opportunity to meet him. So read that book, that guy basically. And also, if you're interested to do instead of Amazon, if you want a cloud, let's say cloud, Oracle Cloud, and there's I wrote on a blog, my own blog, and there's you look at Amazon amarkalvikatte.wordpress.com, you see Oracle Cloud Infrastructure Foundation, which is same like AWS practitioner exam. If you pass this, you just brush up AWS, and with this also you will pass it. And then with this, basically you can cover your basic foundation certification with cloud without trouble. And if you carefully listen my session, I think you will surely pass the exam too. Now, last slide. As a student, I always give 3 advices. I will tell you my personal story for a minute. My father passed away when I was a 4-year-old. I have to leave Mumbai in overnight, and I have to go to my native place, where I went to the farm. I had a buffalo. I need to take them to the grass. I need to clean them. I need to go to school without sleepers. I came from that background. I didn't know how to speak English. I didn't know. I came to Mumbai at the 8 or 9, 9 standard. I stayed in 2 years in Mumbai for 8, 9, and 10 standard. I do not know. It was complete new word for me. Everybody has a color TV. Everybody has talking different, and I didn't have anything at home. Right. I came to Mumbai just for education for 9th, and I do not know how to write English sentence. I don't know how to change the voice and indirect and direct speech. I learned slowly, slowly, slowly. I do not know how to speak English by the time. Now look at this. I'm not scaring, first of all. My English may be not good, but I know how to communicate. I know how to basically convey my message. As I said, I'm a student today, tomorrow, and forever. I'm not an expert. If I'm expert, I'm lying. I'm a student today. I'm talking to student another student because sharing is caring. So my first point is open your wings and just fly. You know, if you don't, you everybody has wings. Nothing wing is nothing but the motto, the fear. You take it out, the monster take it out, and just go and explore. You know what happens at the end? You will fail, but innovation start with failures. If you look at the cycle of innovation, is fail, improve, success, and scale it. If a cloud is all about scaling, yeah. So fail, improve, succeed, and basically scale. That's the first and foremost advice I would like to give as you as a person. If you want to go to the technology, if you want to go to something else, keep the passion of particular stuff. If you want technology, keep passion. I want to do because I love this. I really want to serve the customer. I really want to add the value to the customer. So build your passion and do it. Don't do for money. Money follows. You know, when you have the talent, when you have the knowledge, money comes behind you. They don't they because they want you, right? Rather you want them, they want you. Make sure that you have the expertise. You create yourself as a leader. An important thing is curious, right? And open-minded. Don't say like I know everything. Nobody knows everything, to be honest with you. I don't know anything, right? I know few things because I'm working here. But if you look at something, I don't know if UPSC or IS or IPS, I don't know what they're doing because maybe no, I some working, but internally I don't know the procedures and way of things. I don't know the laws, right? So nobody knows everything, but I'm curious to learn. I'm curious to understand because I'm open. I'm open my ears. I open my eyes, right? So be open. With that, I would like to thank you, SIS College of Engineering and the organizers. It's my tremendous pleasure and honor to be with you all. If you are interested to talk to me in the future, contact me via WhatsApp or LinkedIn and go through my website and ask me to do this and that. I'll be happy to learn. With that, I would like to conclude the session and thank you for bearing with me for closely 2 hours now. And if in the future, if you really want me to talk any other topic, happy to talk.
What a
What
wonderful
a
session,
wonderful
sir.
session, sir.
If you have any
If you have
doubts,
any
please
doubts,
raise them.
please raise them.
You will be given the mic access.
Yeah, so anyone can ask the question, or if there is a questions on the chat, maybe you can read it and we can try to answer it. Anyone has a question, do not, like I said, take the fear out. There is nothing wrong and there is nothing right. Everything is right, right? But you have to open yourself. Even people laugh it, you know. I'll tell you one thing. If you don't ask questions, one thing I would like, people talk for good, people talk for bad. Why should we have to care about people? It's my life, it's my journey, right? If I want to be in the part of the journey, I need to explore. So don't shy, right? Don't shy, open up. Even if I ask the question, if you look at in my presentation, there might be, because I sat yesterday till 1:30 to make almost 60 slides. Before I talked to your team in the morning, I think I was on slide number 2 or 3, but there might be some mistakes in the spellings while doing this exercise. But like I said, it's not like I am 100% perfect and I have to shy here because my spelling is mistake. Don't shy. Open yourself. Ask any question you have in your mind. Or if you can't, I put in the chat so that um, someone can read for you.
Hello, good afternoon, sir. I hope you can hear me.
Yeah.
Sir, first of all, today's session was really amazing and I loved it, like every bits and pieces that you spoke on Google Cloud Computing. But sir, I'm just curious to know that Google Cloud Computing, Amazon Web Services, and even Microsoft Azure, like they serve similar platform. So which platform will be efficient for me to learn cloud computing? What do you think, sir?
Yeah. Well, it's a good question we discussed yesterday also. Like I said, as you rightly said, three of them has the similar cloud offering, IaaS, PaaS, and SaaS. Of course, their architecture is same, region, availability zones. Of course, availability set, somebody said instead of EC2, they said Microsoft and GCP said virtual machine. But it is the same at the end of the day, right? The only thing what you want to do is depends what you want to achieve. Let's say you want to go in a cloud, it's good to have more, right? Means like if let's say you are working in a company, let's say tomorrow you selected to Infosys or TCS or Cognizant or any other, you are going to work on a multiple customers in a mix and match environment. As I said, tomorrow either it will be hybrid or it will be multi-cloud, and you become, let's say, architect or expert. It's better to have the understanding of both the clouds, because first of all you are not going to solve the problem, but you are proposing a solution, and customer may ask, why are you proposing Amazon, why can't you propose let's say Microsoft Azure? But if you don't have Azure knowledge, you cannot propose it because you don't know it. So it's better to have, do one favor, just simple stuff. um, of course certification, I don't focus on the certification first, I focus on the knowledge first. Create the knowledge, make your hands dirty, put the computer, understand everything, compute, network, storage, and the connectivity to the outside world, understand it. Then do certification, 1 or 2 expert level certification on Amazon or Azure or GCP. Then go to another platform and do that, because then what happens, you already know every single bit and piece about that, including the cloud. The next one is what you do, you create Excel sheet where you put, okay, column number 1 Amazon Web Services and this the comparison, and then another services is let's say Google or Azure. Put what if the, let's say compute is EC2, they virtual machine. The database is Oracle, they use, let's say, database instances. Put the differentiation and you know end of the day, right? And then go and do the certification from others, that will be more easy. But focus one first, doesn't matter which one. Of course 3 of them, nowadays everybody using 3 of them. Even if you look at Asia Pac, Alibaba is more utilized than any other. If you look at Oracle, because a lot of customer has Oracle database and more of the let's say Hexadata stack, that means they need to transition to Oracle. But if you know one better, then the other will immediately follow, and you can spend 1 or 2 weeks to get those certification easily. But start one, maybe Amazon Web Services. The good thing about Amazon Web Services is the documentation and everything is very easily accessible, very easily written. Sometimes you feel that complication with GCP and Azure, depends, right? Everybody has pros, the way of taking. But my let's say 2 cents advice is do one, start from a basic, go one level higher, do professional, finish it, understand. Once you understand, then start doing others, then it will be done in less than a month, that expert certification. I hope that answers your question.
Okay, so you mean to say that we need to have a taste of each like every platform, and
Because
of course
nowadays
it differs from person to person, whichever you're
yeah,
comfortable with, right?
but like I said, there is a question of better to have one versus better to have many, right?
Exactly. Yeah.
So the question needs to be answered is like, okay, let's assume that you are a company, only Amazon Web Service provider. Why would you need Azure and GCP, right? But that's wrong actually. Because let's say tomorrow you go to the customer and you say, you know what, we are Amazon partner and we just add, and customer said, you know what, I want Amazon and Azure. Can you basically help me? And then the second question they ask, forget about Amazon or Azure. Why would I buy from you? Why Amazon? But if you don't know the cons about Azure and GCP, then you cannot sell your solution. So you need to make a comparison in front of the customer. You need to make a differentiation why you need to adopt AWS, from functionality, from business value, from costing, etc. Then you will not position your solution, right? I'm not talking
Very
about
true, sir.
you in the first place, but tomorrow you become the architect, you become, let's say, the CEO, and you need to convince the other CEO. Then you need to have the knowledge of everything.
Okay, sir. Yeah, got it. Thank you so much. Thank you so much.
No problem. No problem. Any other question?
Good afternoon, sir.
Good afternoon,
Firstly,
ma'am.
thank you for such a knowledgeable session. And moving on to the question, my question is, as we know in in cloud, data is stored in buckets, and website often access these buckets to get data. So most websites need public buckets, and what if I want to deploy a website which is selectively visible to some people? So how do I do it in cloud?
Yeah, I mean, it's a good question and really like it, and which maybe I did not cover it, but what happens even if you have, let's say, only consume the S3 bucket, right? So bucket is nothing but a bucket which has objects. Objects may be files, right? So you can create policies, right? As I said, IAM is one thing, identity access management, but also you can create bucket level policies, granular policies. So I first create an IAM, of course, to make sure that which user really need to access that. And then you create bucket level policy, and that bucket level policy is again granular to that IAM user. So that means you can basically protect unwanted people to access it. Yeah. I could add additional stuff, but because of the time I did not put it. But even if you Google it or search it on Amazon, you will see that IAM policy plus the bucket level policy. And basically what happens, you basically consume a bucket and you put object on top of it, right? I hope that answers your question. If you are not using even the S3, but of course you use S3 as a front end, what you can do, you create another database or another service as a private, only allow the private users to access private and only public users to access public. And in public, what you can do also additional stuff is only public data you can make it available. The private data you keep it here, and based on the request you can make a communication between public S3 bucket and the private subnet based on the endpoints, and maybe give additional access rules that can allow the specific communication to happen. That way you can achieve it. I hope that answers your question.
Yes, sir. Yes, sir. Thank you so much.
No problem. No problem. But like I said, the more in depth you go, deep dive, go deeper and deeper to understand, so that every question you can answer yourself, like I'm answering you. If I only know the services, then I won't be able to answer. But you need to know how I can design, how I can basically, if a customer says public versus private, then where can I position my storage, right? As you said, data is very important and data should be always available, but data needs to be replicated from one availability zones versus availability. Data needs to be, if you look at Netflix, right? Simple example, Netflix is public service. Let's say tomorrow the Hollywood movie or Bollywood movie is released. What Netflix does, they put the movie into the bucket. Now look at it. Of course, they're public, so that means they need to available to everyone, not to everyone, the only people who has a Netflix account. If they allow everyone, that means they're free. So Netflix will not make money, right? So they have to make that money, of course, but they have to make it available to the users who has a Netflix account. That means they can pay the money, right? So what they do, they basically take that file, take the things, and they roll out to all over the buckets across the globe, S3 bucket, and they replicate it. So basically they copied one and they replicate to all the buckets based on the region, based on the stuff. Yeah. I hope that answers the question some sort. Additional points. Yeah.
Yes, sir. Yes.
Any other question? Or from the professors or from the student, any other student who really want to know more?
So we have a question in the chat section by Swapnil.
Okay. Can you read it for?
He's asking, I'm most confused about APIs. I've heard a lot about ML's APIs in AWS and using them in softwares, but how are they essential in cloud computing? And how do we efficiently make use of them?
Yeah, so see, as I said to you, every cloud, and probably the person who's asking the question, if he's an API expert or Python or JSON expert, he knows some limitations in the cloud too, right? So cloud has their own API, yeah, and those are proprietary to them. That means some of the APIs which are already written, you cannot customize it, yeah. That means they are not open source, they are not let's say developer centric, they are in only the AWS centric. That means you use it, but you cannot modify it. Of course, you can do additional part. There's a API management. but again you need to pay for it, where you can customize your APIs, you can write it and basically make interface. But there are fixed APIs, there are proprietary APIs which you cannot modify. For example, let's say uh, the private EC2 instance need to talk to the S3 bucket. Of course, there is an endpoint, but ultimately that endpoint has an API interface, right, to connect to each other. Storage API, right? But of course, these are that proprietary which you cannot modify. You just attach it and you just do that. But you cannot basically customize, or you cannot basically modify the codes behind the scene because they are proprietary, they are fixed APIs. Of course, if you need to create, you need to consume an API management even for another external parties and wants to interface internally, you need an API management. But if you look at open source, like if you have the Red Hat Linux, or OpenStack or Kubernetes, there you can create, like Google is bringing the platform called Anthos, which is on-premise platform on public cloud based on the Kubernetes, which is master node you run in public cloud, and worker nodes, which is where you run the container pods, you run on premises. There you can customize your APIs, you can build it. But then if you really want to build and customize everything, you need separate platform. Then Google is the best one in that case, because they're bringing Anthos on-premise, as well as you can customize that in the public cloud. But the choice is yours. It's not limited, or you cannot do anything, but you need to adapt to which provider versus which provider, depends on use cases. But API is everything, right? Application programming interface API, everything is accessed based on the API only. So API is basically foundation for every single business, and RESTful API, which is open source, is key for us, where anyone can customize it. I hope that answered the question the person asking. If he need more specific and more time to understand even deeper, he can reach me out and I can take it as an additional subject one-to-one there.
Yes, sir, he messaged. Thank you, sir. It was very insightful.
Okay, thank you.
Hello, sir.
Yeah, go ahead, man.
Sir, I have a doubt. Sir, you talked about software as a service and platform as a service. Let's say I want to deploy a static website. What would it fall under? Means, will it be a full stack development?
Yeah, it's a good question. And I think that's the question I was really looking for, because that's where I will bring you back here. Because if you look at, right, let's say now you have front and back end knowledge. Let's assume that you are a full stack developer, right? You know the front end, you know the back end, full stop. Now let's say I'm a customer, and you coming as a service. Let's say I want to do full stack for you, customer A, and I said, okay, that's a good idea. Then, but my own wish is, I don't want you to build applications. I want you to basically also do the operating system, manage the operating system, as well as managing the runtime or middleware in between, right? If that is a wish of a customer, what you do, you take the infrastructure service model. Of course, you do front end, back end, which is full stack. You run it, that's no problem. But if customer said, you know what, you also additionally need to manage the operating system for me, then you propose the infrastructure as a service model. Clear? If customer said, you know what, I only manage the application, whether it's a front end, whether it's a back end, and the rest I don't want anyone to manage. You don't need to manage anything. You just need to manage a application, that's all, and you come up with a solution. So that's where you propose a platform. That's where, as I said, you create a build phase where you developers only write the codes and roll out the applications, which is a CI/CD pipeline, is continuous integration, continuous delivery, where you write a code with runtime. You can just run your code. If everything goes green, you push that code into production, right? So that's where you bring reality. But like I said, it's a customer choice. Customer said, I don't want even the application to be built. The application needs to be consumed. Then only you take SaaS model. But if the question of yourself as a full stack developer, where SaaS doesn't come, because here you are not developing anything, because it's already developed, you just consume the application. So this is out of equation. Now go back to the second one. If you are not managing the middleware, etc., which is part of the full stack, then you only manage the 50%, which is only application related, whether front-end application. So you write the front code Java codes, but backend is nothing to worry about. Or even if backend is part of the application management, so you just maintain front end backend, but runtime and OS you are not managing. There you propose platform as a service. And like I said, if your customer said, you know what, we are not in the cloud, but we are on-premise, but you take everything from us, front end, back end, full stack development, but also managing the operating system, storage, etc. Then your company, maybe Infosys or TCS, or be part of that particular company, you manage the front end, back end as the application stack. The infrastructure team will manage the infrastructure stack, right? So it's a combination of both. But like long story short, depends what customer wants, you manage it. If they want only application, you provide the platform. If they want application per operating system, you provide IaaS platform. And if you want customer know nothing from you except consumer application, you offer a SaaS as a platform, right? There you don't need to do any full stack development here because the application is fully developed. It's clear, or it's not clear for you?
Thank you, sir. It's clear.
Okay, fantastic. Any other question?
So I guess I hope all your doubts are cleared. I would now request Atulya Anand, our IEEE representative, to present a token of gratitude as well as deliver the vote of thanks to a speaker.
Am I audible?
Yes, you're audible.
Okay, so a very good afternoon to each one of you present here and to our esteemed speaker as well. On behalf of the entire team, I would like to extend a special appreciation Mr. Amar sir. Sir, it was truly a worthwhile session and a great start to our morning, I should say. We are more than proud to have you with us and love to hear out your impeccable journey and knowledge. I must say it was truly an insightful and inspiring session for all of us. Thank you so much for lending your precious time with us today. We are extremely grateful to you for obliging us and conducting this webinar, although it is a Sunday early morning for you. And we are looking forward to having many more such collaborative events along with you in the near future, and hope you enjoyed doing this event with us as much as we did. And on this note, I would like to wish you all the luck for all your future endeavors. Here we have a small token of gratitude for you on behalf of the entire team. And yes, of course, no event can end on without a bunch of incredible audience just like you. I hope there's a lot of intuitive content for you to take back in order to enrich your expertise. So make use of this platform, and thank you so much for encouraging us with your enthusiasm and undue support. And once again, a very big thank you to Mr. Amar sir for being with us today. It was truly an honor to have you, sir. Thank you so much.
Thank you so much. Thanks a lot. Take care, all of you, and stay safe. Thank you.
Thank you so much, everyone. See you on day 3 of WEBCON, that is 8th of November. Thank you.
Thanks so much. Have a good day.
Thank you, sir. वेट करना है हमको?
No. Everyone can leave.
Bye. Thank you.
Thank you, everyone. Hope to see you at the next session.